Okay, let me just double check here. All right, let's see. Still good to go. And let's see. What is a conjugate acid and base pair? Wow, fitting. Conjugate acid and base pair. So what this question is asking for is, how do you identify what the conjugate acid and base pair is? The key difference here is that there has to be one proton difference, okay? So, for example, if I gave you H2SO4 and HCO3 minus, yes, the CO3 minus has one less, the HCO3 minus has one proton difference, but you can see here that there's one that's the sulfate ion and one that's a carbonate ion. Those are two different structures, really. They won't be the conjugate acid and base pair of each other. What you would be looking for here would be HSO4 minus and H2CO3 right here. Those would be each other's conjugate acid and base pair. The key thing is that there's one oxygen difference. Another example would be H2O and OH minus, okay? These are conjugate acid base pairs. Now in regards to telling me which one the conjugate acid and the base is, the one with the extra proton is the acid, the one with the less proton is the base. So this would be the conjugate acid here, this would be the base here, okay? And another example, if I gave you this H3O plus and OH minus, these are not conjugate acid base pairs of each other, because now the difference between them isn't one but two hydrogens. So in reality, the conjugate acid base pair for this, both of them will be water, but that's because the intermediary step. So if I actually did this, H2O like that, between here, okay, this would be the conjugate acid, conjugate base, and here this would be the conjugate acid, and that would be the conjugate base, like I said above. But exactly these two here would not be conjugate acid base pairs of each other, because there's more than one proton difference, okay? So that's a key thing. Difference by the presence and absence of one proton is a conjugate acid base pair. For example, they give the example of ammonia versus ammonium. This is a conjugate acid because there's one more extra proton, and when ammonia is a base because it's one less proton. So this is correct. And with that, I've just stressed exactly, look for just the slight differences of just the one more proton or one less proton. That can be the only difference there. You will notice a charge change, but hopefully for the molecule itself, you can say that's the only difference there. So even if I had H2SO4 and then HSO3 minus, this is sulfuric acid, and this right here is hydrogen sulfide. You can see here the difference is that there's a 4 and a 3 oxygen. Those two will not be conjugate base pairs, even with that slight difference, because different amount of oxygens. All we're looking for is that they differ in one proton, the hydrogen. So now question number 14.